I'm Algebra Annie, and I am here to help you be successful in your algebra class. It always seems impossible until it is done. Nelson Mandela. Our learning targets today are: I can match simple graphs with situations. I can graph a relationship.
Now we're going to talk about graphing relationships. So in this graph, we see that we are looking at time, and as time goes on, we're going to be looking at what happens to the temperature. So we read from left to right, which meaning as we go over here, time is getting further and further away. So what happens to the temperature as time goes on? You'll notice that there's no numbers on our x-axis or our y-axis. To help us see this, we're going to put numbers on. And so just so we can get an idea of what's happening, since this is the first time we're seeing it, let's pretend that the y-axis was graphed by fives. So 5, 10, 15, 20, all the way up to 45. So I can see when I first started, what was my temperature? My temperature was 15. And if I kept going further down, I could see that my temperature remained 15. So if my temperature was 15 this entire time. A flat line is a constant line. So this is a constant temperature, which meant it remained the same temperature the entire time. For us, it remained 15. What is happening to my temperature as time went on? So right here it was 15. Time went on, and I see that, so this time corresponds to here. That's about 25. You go on a little more. I see it went to 40. So what's happening if I went from 25 to 40? I see that my temperature rose. So my temperature rose. It went up. And then something happened. What happened right here? So at this time, it was still rising, but then what happened? It looks like my temperature started going down. So it started going down, and then right here, it immediately stopped. So it dropped sharply. So this was a sharp stop. And then we had a very straight line. Straight line, as we know from over here, was constant. So if I had to read this, my temperature was constant for a while. It rose steadily, and then my temperature went down to a sharp stop, and then it was constant the entire time. So we're going to use another graph to see if we can find a trend of what it means to be a horizontal line, a slanting upward line, or a slanting downward line. Remembering we always read from left to right. So we're going to start on the furthest left. We're going to map the line as we go from left to right on our graph, and we're going to see what's happening. So we started off our temperature right here, and I can see that my temperature went like this. This is slanting upward. Since we were slanting upward, what was happening to my temperature? My temperature was slowly rising. So my temperature was rising. So it stops abruptly right here, and then I don't go up or go down. I have a horizontal line. If I don't go up or if I don't go down, I know that I'm constant. So this was a constant temperature. Horizontal means constant. Another way of thinking constant, it stayed the same. It didn't go up, it didn't go down, it stayed the exact same, it was constant. Well, then I see an abrupt change, and reading from left to right, I go down. So going down was dropping. So my temperature is slowly dropping. So I want to look at a couple of different rises you could do. So you just watched your slope dude video. And if this were a mountain and you were slowly rising up like this would have been a slow rise, like slope dude was showing. If you think of it as a mountain and you are going up the mountain, this would have been like a consistent rise. So this would have been a constant rise. It rose steadily. How do these lines look compared to a mountain that went up like this? The black mountain line would have been really easy to hike. The red would have been a little more difficult. Why would this green mountain be extremely difficult to hike? It's because it rose really rapidly. This is a very steep line. So this is a rapid rise. These are all rises because we read from left to right, and they are all going up. So these are all mountains, but you can rise slowly, you can rise steadily, or you can rise rapidly. It's the same exact principle as before, but now we're falling. So if we were up here on our mountain and we were falling like this would have been a slow drop or a slow fall. How does that compare to a mountain that would have gone like this? This would kind of been a consistent drop or a constant drop. Now, what would a very sharp, drastic drop look like? So this would have been a very drastic drop. So this would have been a sharp drop. If you had to go down a mountain like this is very steep compared to a consistent drop or a very, very slow drop. So there's a special graph I want to talk to you about. This graph is looking at theme park attendance, and as the years go on, the number of people. What happened to the number of people? We can see that there was a downward going trend for the number of people as the years went on. But something special about these points, you will notice that they are not connected. They're not connected, and that's not a mistake. They're not supposed to be connected. This is made correctly. So if I was looking at this dot, this point in time is a different year than this particular point in time. So if this was year 1, and if this one was year 2, just to give it a count so we could actually look at it. For the number of people that showed up in year 1, does that influence how many people show up on year 2? The number of people that showed up on year 1 have nothing to do with how many people show up on year 2. How many people showed up on year 2 have nothing to do with this point over here on how many people show up on year 20 or say year 30. These dots have no impact on one another. So I want my points to remain not connected. If they are not connected, then this is called a discrete graph. I want to show you another example of a discrete graph. So these are not connected. And this is actually a correct graph. They're not supposed to be connected. This is considered a discrete graph. Now, how do I know if it's discrete or not? So I'm looking at a graph that is considering Simon's earnings by the number of candies he sold and the amount of money that he earned. If this represented house 1 and this represented house 2, does house 2 care at all how many candies were sold at house 1? Does it affect one another? It doesn't. So we cannot connect these. Similarly, if this was house 1 and this was house 2, you cannot tell me what happened at house 1.5. So you could not connect these, because if you did, you would have been able to find house 1.5, which doesn't make sense. So if you cannot count the numbers in between, then you can't connect them. If house number 2 has no effect on house number 3, then you do not connect them. So I want to take a look at this graph. This is looking at the length of Allie's hair. As the number of days go on, how long is her hair? This is currently not connected. Let's see if that's actually correct or not. So if this was day 1 and this was day 2, we're looking at her hair as it's going on. Let's say that was 3, let's say that was 4. Does it make sense to connect them? So if I connected them, then you were telling me that I could figure out how long her hair was here, how long her hair was at this moment in time, how long her hair was at that moment in time. So does a person's hair grow constantly, or is it say, oh, today I'm this high, oh, all of a sudden I grow and now I'm this high, and I don't grow at all, and all of a sudden I spurt out and I'm this high? Does it make sense to all of a sudden jump from length to length, or does your hair continually always go up, and is your hair always growing? If your hair is continuously always growing, which it is, this is called a continuous graph. So the length of someone's hair is not discrete. These points should have been connected because I am always growing and things are always changing, and I should be able to figure out at any moment in time how long the hair is. It does not jump from length to length depending on the day. It is continuous.
What did we learn today? I can match simple graphs with situations. I can graph a relationship. And I look forward to seeing you tomorrow in class.